In this module, we're going to focus on reaction predicting. So you've seen a lot of this before, but now we're going to actually start identifying what they're called, why they're happening the way they are, and you guys will start being able to predict reaction products yourselves. So you need to be able to identify and predict the products of various reactions, including double displacement and single displacement reactions, metallic and non-metallic oxides, which are known as anhydrides, combustion reactions, you've already seen that coming into play, synthesis reactions, and decomposition reactions. So first, let's talk about some double displacement reactions. In a double displacement reaction, you have a neutralization reaction that produces a gas. We saw that when we talked about a reaction of sodium bicarbonate, NaHCO3. I think we had it reacting with sulfuric acid, I don't remember, but let's react this with HCl. If this reacts with HCl, I would form H2CO3 plus NaCl. But this H2CO3 further decomposes to form water and releases CO2. Carbonic acid is what makes the bubbles in your drinks. So if an unstable compound is formed, it will decompose to form a gas and water. If you are doing a reaction and you form one of these three species, they will further decompose to form water with this gas. So if you've got carbonic acid here, H2CO3, you're going to form water and CO2 will be released. H2SO3 forms water and SO2. And H4OH, stuff smells disgusting. Ammonium hydroxide is nasty smelling. Not that many of them smell great, but this one's really bad. Forms water and ammonia. Ammonia is what smells. But that's what forms our bubbles. It's the release of that gas, whether it be CO2, SO2, or NH3. So when you're doing a reaction, if you see one of these things come up as a product, H2CO3, H2SO3, or NH4OH, you need to recognize they will immediately decompose to form this. As an example, let's write up a few reactions. We've got calcium carbonate, CaCO3, reacting with hydrochloric acid, HCl. We swap partners here. Calcium to carbonate, or calcium to chloride, carbonate with your proton here. How do I know to swap partners? Well, that's what double displacement does, is they swap partners. So let me rewrite this up here. CaCO3, HCl. And so you can see this as Ca2 plus and CO3 2 minus, H plus and Cl minus. And you're going to swap. The cation is going to react with the anion of the other species, anion and cation of the other species. You're going to form CaCl2, we do have to charge balance here, plus H2CO3. This is not balanced yet. I'll deal with that in a sec. But I see that I've got H2CO3 here. This will further decompose and what I have for my ending products is CaCl2, aqueous, plus water, liquid, plus CO2, gas. Put 2 in front of here, and we are balanced. So this is kind of an intermediate. As soon as this is formed, it will break down to form these two products. Ammonium nitrate and sodium hydroxide. We're going to see a similar pattern. Ammonium nitrate, ammonium, NH4 plus, nitrate, NO3 minus, sodium hydroxide, sodium, Na plus, and hydroxide, and OH minus. So I've got NH4, NO3 reacting with NaOH. And when I immediately swap partners, I'm going to write this out as forming NH4OH plus NaNO3. But I need to recognize I've got NH4OH here. That's not stable, and it's going to decompose. So my actual products will be ammonia, gas, which will be released, water, always a liquid, and sodium nitrate. Sodium sulfite and hydrochloric acid. Sodium, Na+, sulfite, remember sulfate is SO4 2-, so sulfite is SO3 2-, hydrochloric acid, H+, and Cl-. So I've got Na2, SO3, aqueous, reacting with HCl. I swap partners here and I form NaCl and H2SO3. Balance out my reaction, but I see this and I know this is not going to stay. So that immediately decomposes. I form NaCl, water, and what's left over once the water's taken away is SO2 and gas form. And the SO2 gas will leave the system. So this leaves the system, this leaves the system, and this leaves the system in the form of gas. What about single displacement? A more active element replaces a less active element. So a metal replaces a metal ion in a compound. You're not responsible for predicting which metal will lose electrons easiest. It will be obvious from the question. A nonmetal replaces the nonmetal in a compound. In here, the halogens play the king of the mountain game. The ones with the largest electron affinity have the top of the group. So, you know, fluorine is higher than chlorine, is higher than bromine, is higher than iodine. Fluorine really likes electrons. They will steal electrons from the halogens below. Electrons are transferred, oxidation states are changed, and these are redox reactions. So aqueous copper 2 sulfate. Copper 2 sulfate, CuSO4, because copper 2 is Cu2+, sulfate is SO4 2-, and iron pieces just means iron. This is going to form iron sulfate, and copper solid. Fluorine gas. Fluorine is a diatomic. Reacts with a solution. Solution suggests that it's aqueous of potassium chloride. I will form KF and Cl2 gas. I do need to balance this reaction. I've got 2 fluorines here, so I need 2 fluorines here. 2 potassium, 2 potassium, 2 chloride, 2 chloride. Now the reaction is balanced. So again, the metal replaces a metal ion in a compound. Iron is replacing copper. You will not be responsible for it. The way I have it written tells me aqueous copper sulfate is going to react with iron. Therefore, iron has to replace the copper. Nonmetals replace nonmetals, so fluorine will be able to replace the chlorine in its compound. These are redox reactions. So if I was to look here, copper here is +2, and here is 0. Iron here is 0, and here is +2. That means that copper was reduced, iron was oxidized. Fluorine here is 0, fluorine here is -1. Chloride here is -1, chlorine here is 0. That means fluorine was oxidized. It lost electron, I said that backwards. Fluorine was reduced. It gained electrons, whereas the Cl- was oxidized. This should say 2 plus here. Cl- was oxidized. It lost electrons. Metallic and non-metallic oxides in water. So non-metallic oxides plus water form an acid. Sulfur dioxide, SO2, plus water will form H2SO3. So we just add all that up. We've got 1 sulfur, 3 waters, or 3 oxygen and 2 hydrogen, H2SO3. It forms an acid. Non-metallic oxide, non-metal oxide plus water forms an acid. The oxidation number of the non-metal does not change. Metallic oxides plus water form bases. Magnesium oxide, MgO, plus water will form MgOH2. So non-metals plus the water, non-metal oxides plus water, in metal oxides plus water. Non-metals with water form acids, metals with water form bases. Combustion reactions, you should already have a pretty good understanding of combustion reactions. You've got hydrocarbons, which is just carbon and hydrogen containing compounds. So for example, CH4 gas, methane gas plus oxygen is a diatomic, forms CO2 gas and water. Alcohols, carbon, hydrogen, oxygen containing compounds. Here we've got ethanol, which is the alcohol that is safe to drink. Ethanol reacts with oxygen to form CO2 and water. And if I want to balance this out, I have 2 moles of ethanol reacting with 7 moles of water to form 4 moles of CO2 and 2 moles of ethanol reacting with 7 moles of O2, or oxygen, forming 4 moles of CO2 and 6 moles of water. We also have synthesis reactions. Synthesis is when 2 things combine to form something else. Something is synthesized or something is produced. The compound that's synthesized from 2 elements. So synthesized, prepared, produced are some other words for that. So your sodium plus your chlorine. Sodium plus chlorine gives me NaCl. But remember, sodium is Na. It's a metal, it's a solid form. Chlorine is a diatomic, Cl2, and it is gas. It will form NaCl, but this needs to be balanced. The chlorines need to balance, and now my sodiums need to balance. Aluminum pellets, so aluminum solid, reacts with liquid bromine. Bromine is a diatomic, and I will form AlBr3. How do I know it's AlBr3? Well, because I know Br will be -1. I know aluminum is +3. Therefore, I got to have 3 bromines for 1 aluminum. Balance this out. Okay, so here, metals are losers. They're going to lose electrons to form your cations. Nonmetals form anions by gaining their electrons. The electrons are transferred, oxidation states are changed. These are redox reactions. This went from 0 to +1. This went from 0 to -1. 0 plus 3, 0 minus 1. So synthesis reactions are redox reactions. In decomposition reactions, most compounds will decompose to form a gas, O2, CO2, SO2, H2O, and a leftover compound. Heat, electrolysis, catalyst is usually necessary to be able to cause this to happen. But can you recognize trends? Which ones are redox here? If these are decomposed, copper hydroxide decomposes into copper oxide plus water. So copper 2 hydroxide, CuOH2. Remove the water, I get CuO and water. In this case, this will probably be a gas because I'll probably have to heat it enough that it will actually be in gas form. Potassium chlorate, KClO3, gives me KClO plus O2. There's no hydrogens here, so it can only give me O2. Copper 2 carbonate, CuCl3, gives me copper oxide plus CO2 gas. How do I know what it's going to give me? Well, they're always going to give me some kind of O2 containing thing of some sort. But I've got a hydrogen here, so I'm going to form water. I only have oxygens here. I'm going to form O2. I've got a carbon here. I'm going to form CO2. Are these redox reactions? Well, here copper is plus 2. Here copper is plus 2. Oxygen within hydroxide. Oxygen's minus 2. Hydrogen's plus 1. Oxygen here is minus 2. Minus 2 plus 1. Nope. Potassium chlorate. Wrong button. Minus 2 for each oxygen. Overall, minus 6 charge. Potassium can only be plus 1. So the chlorine here must be plus 5 to make up the difference here. Minus 2, plus 1. Chlorine's got to be plus 1 here. And 0. This is redox. My oxygen went from negative 2 to 0. My chlorine went from plus 5 to plus 1. Can you recognize which one's being oxidized, which one's being reduced? Oxidation is loss of electrons. Sorry, I'm trying to write definitions here and I'm not paying attention where I'm at. Oxidation is loss of electrons. Reduction is gain of electrons. And I can't spell. So which one's losing electrons? Which one's gaining electrons? This went from negative 2 to 0. That means it's been oxidized. This went from plus 5 to plus 1, meaning it's been reduced. Copper carbonate. Carbonate here. Oxygen is minus 2, overall minus 6. Copper is plus 2, because it's a copper plus 2 compound. So carbon here must be plus 4. Oxygen minus 2, copper plus 2. Oxygen minus 2, overall minus 4. Copper plus 4, not redox. So the only one redox here is this one. Let's look at these reactions. Ammonium carbonate, NH4, 2, CO3, decomposes to form water, CO2, and ammonia. All of them. How do I know it's going to form all? Well, I've got a nitrogen here, I've got a hydrogen here, I've got a carbon here. Carbonic acid. H2CO3 decomposes to form water and CO2. That's what forms the bubbles in your drinks. Sulfurous acid, H2SO3, decomposes, forming H2O and SO2 gas. And hydrogen peroxide, H2O2, decomposes to form H2 and O2. And each one of these bubble when they react. So practice these, see if you can try to predict what products are coming out of this, and see if you can identify what's redox and what's not by assigning oxidation numbers.